Okay, so I wanted to send this over. I reworked the panels that everything mounts to try to avoid putting the Teflon ring here, and I think this will work. Well, I know this will work. The only drawback is these panels can't be mirrored from one side to the other now, so that's going to be a little bit more expensive. I don't think building two of one panel versus one and one of the other. I mean, yeah, you're going to see a little bit of a cost savings if we could mirror them. But it just kind of comes down to are we trying to save a little money by being able to mirror the components versus, I mean, what's it going to cost to get those Teflon rings made, and how effective are those Teflon rings going to be? One concern I did have with the Teflon rings is this hardware here is only 440 hardware. And so the longer that screw, you're increasing the length of that screw by at least a quarter of an inch. And that's really all you're counting on when you come to the twisting of those fittings going on, is those 440 screws. Those are small screws, and the longer you make them, the weaker they're going to be there. So if we could avoid that, that'd be nice. And so what I ended up doing was really just kind of following a circular pattern around the fittings on both the top and bottom, and still trying to maintain some support as well while, trying to not, I might add some perf in here or something, just trying to reduce the mass. But what it does is it allows you in these instances where you've got all your pins going in here, you can come off your pin, you can do your radius and go down and solder into each of those individual points. And so when you look at it, I mean, the back of the connector is still only 0.07 off of the face of that board, but you've got this entire open area back here to come with your cables. So if we look at it from this direction, let's see if I can that way. Yeah. If you look at it from this direction, then essentially what you would have is, let me see if it'll pull it. If I can pull a dimension here, that should be the top of the connector to this edge. There's 0.28 inches. Just confirm that. Yep. So you got 0.28 inches right there. And so that means is you've got your wires coming out of the back of this connector, pulling their radius, coming back and connecting to the board here. If you do a 0.25 inch radius, it's not even going to get up beyond that edge. It's just going to be living in this whole area. So one other thing to look at was, how does this affect the sliding in and out of the rack? Now I haven't modified the original pieces. These are all just kind of new parts. But I'm going to pull up the original rack here, because this will show that if you measure from the back of the connector here to the front face that you'd have to worry about sliding across, it's 0.44 inches. And so what that means is that this component right here can hold the same type of circular pattern. It doesn't have to have like a slotted pattern to allow these boards to slide in, as long as we keep the wire depth below 0.44 inches. So if we shoot for 0.25 and go slightly over that, then what you're going to end up with, see if this normal view will help, what you're going to end up with is you've got a wire that comes back off of here, extends through the opening in these two plates, which is on the other assembly I just showed you, makes its turn and comes back around and goes in the board, but stays clear of this one. So that's where we're at there. I can look at slotting those open, but I really don't think that's going to work, just because of the size of the circular openings here on this guy. But I think this might be a good option to provide an area for those wires, enough depth for those wires, while not having to do anything with that Teflon ring. And that way the connectors can be mounted directly to the board. So I've got something similar started on the other side, but wanted to stop right here, let you take a look at this, see what you think before I put any more time into it.